Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. Everyone, welcome into the program. I hope that you're doing well and you are ready for the show today. Because today on the show, I'm excited to have the one, the only, we're going to have Edgewater Wireless, and we're going to be talking about, not just Wi-Fi. I think we all have, our routers in our homes, and we're all very happy when it works and very upset when it doesn't. This is even more important because, hey, if you have a place of business and people can't connect to the internet, they're probably more likely to leave and not enjoy their time there. It's very, very important to have good connectivity everywhere, for not just for your customers, but also for your equipment and so many other things. But we're going to get into how our guest is aiming to fix that and actually make that better for everyone out there. But before we get to that, everyone, computeramerica.com. That's where you'll find everything, including the show notes. For today, we'll have a link to our guest website. We'll have links to any articles that we talk about. And of course, we have tons of past shows, everything from interviews to giveaways, contests, video archives, audio archives. Ladies and gentlemen, computeramerica.com. That's where you'll find everything that you need to know. Now, with that being said, I think we should just jump right into the interview and, get this going. And as I said before, Edgewater Wireless, if this is your first time, that's okay. We're going to assume nothing on your part, and we're going to give you a great overview of the company with the president and CEO, Mr. Andrew Skafel. So let's go ahead and bring him on. And Andrew, welcome on to Computer America. How are you doing?
I'm doing great. Thanks very much for having me.
Our pleasure. So I think that a good place to start, as always, is the beginning. And tell us a bit about Edgewater Wireless and kind of what the mission was when the company started, and also a bit about yourself. How'd you find yourself at the head of this company?
At Edgewater Wireless, we make Wi-Fi better. So we've taken a dramatically different approach to Wi-Fi. Really, Wi-Fi's been unchanged since 1999. It's always been based on what's called a single channel architecture, like a single lane road, where all the devices share that single lane. And just like a single lane road, you put a lot of devices on it and traffic gets jammed, and you get that universal, painful Wi-Fi experience. At Edgewater Wireless, what we've done is we've looked at the problem and said, how do you solve a traffic congestion problem? And we've built and patented the first multi-lane highway for Wi-Fi. So we add physical lane capacity that allows you to spread the devices over more lanes or more channels.
Go ahead. Yeah, no, I was going to say, and we're definitely going to get into the technology behind that, but that seems like such a, I'm glad that you were able to break it down into very understandable terms. Let's go ahead and finish the intro, and then I'm going to start peppering you with questions, but please.
Oh, that's great. Well, so we're a spinoff from a military R&D company. So the technology has had quite a bit invested in it, and it's a highly innovative approach to solving the challenges that face Wi-Fi. And my background, I've been in the technology space for longer than I care to admit, over 20 years now. And what really brought me to Edgewater was the core innovation of the technology and the people. It's quite a really interesting approach to doing something that's highly differentiated and really targeting where the market is going. With all these increasing device density and things like that happening.
And we're definitely going to showcase that. I'm kind of curious about, with you being a spinoff of a military R&D idea. I'm actually kind of curious, real quick, if you want to, we can branch this off into use cases, but use cases for the military. I'm kind of curious, kind of what line were they chasing when, this idea and this, this spectrum slicing technology, kind of came about, and what other problems does it solve other than military? What are the other applications?
I think the military company got involved, because they saw an application for non-line of sight airplane to airplane communication using a multi-channel architecture or multi-channel radio architecture. Now, the technology really lent itself well to Wi-Fi. So eventually, we focused the company in on the Wi-Fi opportunity, spun it off, and over the past while, we've really determined where the technology fits in the market. Initially we started out in the venue space, where device density was really a challenge early on. And, through our work with cable labs and some select tier 1 service providers, we've determined that the home is probably the most problematic space for Wi-Fi today.
Do you think that and for people out there who are already experiencing this and people who haven't yet, because let's face it, between digital assistants and, we just went through a renovation at my house, now we have like 3 microwaves that are connected to the internet. We have our, a fridge that's connected, and that's just the kitchen, going everywhere else with light bulbs and security systems and things like that. How big of a problem do you see this being going forward? Like, if we change nothing, do you think this is something that everyone would would have to deal with eventually?
Absolutely. I think, your house is not uncommon, right? With all of these, Wi-Fi or wireless connected devices that we've come to rely on. And when you layer on that, the global shift to work from home, things like that took place over the pandemic, Wi-Fi has become mission critical. There's over 4 billion Wi-Fi devices shipped last year.
Wow.
And that's 20 billion that are installed and operational today. So it is a phenomenal success story, but it's also created a massive challenge with that device density. Because if you think way back to 1999, the vision for Wi-Fi was, you sitting in your basement connected with your big laptop to the access point, and you were the only device. Today, your home, like my home and most other homes, looks very different from that.
Yeah, definitely a lot more, like you said, device density. I think you've laid out the problem very well, and we can also extend that to businesses and venues like you were talking about, where, maybe a business, actually a venue would be a better case, because, when nothing is happening, you need like 100 devices, maybe, some cameras here and there, maybe some people, whatever. And then when you host, let's say a concert or something like that, suddenly you have 100,000 devices trying to connect to the same network. And that, to have that kind of flexibility, I'm sure, is an extreme challenge. So I think we've laid out the problem. Let's talk about the solution a bit. And spectrum slicing, that whole thing, we're going to show some images on the video portion, that we can, of course, refer to. But Andrew, if you wouldn't mind, go further into the analogy of, spectrum slicing, highway, multi-lane. How does this really work? Is it backwards compatible? Yeah.
One of the key things about the problem, just to frame the problem statement a little further, is we last connected, I think it was pre-pandemic, right? And then I think we were discussing about 40% of customer care calls at major service providers was Wi-Fi related. Now, if we fast forward to today, a week ago at a major industry conference, I was speaking with a tier one operator, and they said 70 to 80% of their customer care calls are now Wi-Fi related.
Wow.
So this problem has just exploded. Now, when we talk about our approach of spectrum slicing, we're the first folks that are able to take that spectrum and divide it up. So the graph at the top there is a beautiful example of what spectrum slicing looks like. If on the left, you have the 2.4 gigahertz spectrum, traditional legacy Wi-Fi can support one channel at a time in that band. So the entire band is wasted. And with 5 gigahertz, they might be able to squeeze one at the bottom and one at the very top and use some expensive filters. Now, using our patented single signal processing techniques, we can put in more physical channels or links within that spectrum to allow transmit and receiving. Those look like, for your devices at home, they look like just another access point. Yet the physical capacity is greater. Now, why that's so important is when you look at Wi-Fi itself, it's a contention-based protocol, right? Each device goes on that channel, and then you have to cycle through to the next device and the next device and the next device, all the way through those shared devices that are all sharing that lane. And it means you've got a slow device, they're all slow. Now, just by reducing the contention and spreading those devices over more physical lanes, the contention's resolved, and you get this massive improvement to latency, which is probably the killer of performance.
Yeah, and I'm kind of curious because you mentioned 2.4 and 5. I think a lot of people are familiar with, either just the standard Wi-Fi and then the 5G that they may be seeing if they have a newer router, which actually might be pretty standard at this point. But yours operates in the 2.4 gigahertz, right? And you said it looks like just everything else. I'm kind of curious about with this technology, because one of the problems that people run into in businesses as well is that 5G is faster, has bigger, has larger bandwidth, can handle more data, but it's much more prone to obstructions. It can't go through walls as well. Sometimes it can barely reach in the same room like I deal with. How does your technology handle some of the more common problems of wireless? Is it, does it solve any of them, or is it just the same problems, just better standard?
Actually, that's a great question, and you really hit to the root of the physics behind any radio communications, right? 2.4 gigahertz, just by the spacing of the waves and everything, it propagates, or it goes much further than 5 gigahertz, roughly twice as far, for example. Now, one of the big developments that's taken place over the last few months, or last six to 9 months, is the FCC has released a new spectrum that Wi-Fi can also use in 6 gigahertz, right? So that 6 gigahertz being higher up goes even shorter distance, right? So there's this enormous distance problem, right? That we've got more spectrum, really cool, very excited about that, but doesn't go very far. So, what we've done with our approach, and this is really fast forwarding to some exciting news that we've got coming out about our new WiFi7 platform, is we've allowed the access point to determine the best channel and the best channel width to operate on. So the narrower the channel, the more it can, or the further it can penetrate. It's like trying to put a 2x4 through a wall versus a nail, right? The narrower channel penetrates much better. So, a lot of those distance issues we solve very elegantly. I'd say that our technology lends itself very well to solving some of those issues.
I gotcha. So still, so some of the same issues, but of course, you know, with your technology in your routers, you're able to more intelligently handle the traffic, and that's something that we've seen a lot of improvement on because, you know, you kind of mentioned we're talking about physics here. You can't really change that. You can't really upgrade how radio waves bounce around and, you know, kind of do things, but we can make the technology that handles our communication do better. You know, less packet loss and, you know, just more redundancy, better. And I think redundancy is something that we should maybe touch on. Is that something that the Edgewater Wireless is working on? Because, you know, it's one thing to have 100 devices on, you know, 3 different channels instead of 1 different channel. With those further lanes, are you able to, you know, you mentioned that it will automatically pick you the best one. Can it also handle redundant traffic or, you know, maybe improve stability for one channel and, you know, by using those multiple lanes?
That's a really forward-looking question, right? Like
Okay.
one of the cool things about our approach is, you know, not only can we do, let's say, those 3 channels in 2.4, 5, or 6 gigahertz, but we also, because of the architecture of our radio, we're not limited to using a narrow band radio, right? We use a wide band radio, so we're doing full band capture in 2.4 gigahertz, for example. And so what that does is allows us to actually have a real-time spectral monitor, and what we call our SSA technology running. And that spectral monitor can actually identify sources of interference. And using some software on the upper layers, right, we can help steer the traffic to the least congested or the least interference impacted channels, which gives you some redundancy in terms of choice. Now, further pulling on that string of redundancy, you know, we can we'll talk a little bit. I'm probably a little bit later on about Wi-Fi7 and some exciting features that are coming out there that really line up well with spectrum slicing.
Absolutely. And actually, why don't you go ahead and talk a little bit about making sure that everything just kind of works. And this is, I think, one of the best things that a technology can do, because I think a lot of people out there that are like, I can make the internet better, I can make it more decentralized, I can make it faster, more secure, more private, and they're like, great, how do you do that? And they're like, well, first we have to dismantle every server, rebuild the entire thing from the ground up, and yeah, you know, we can make a better internet. It's like, yeah, but that's, you know, if there's no backwards compatibility, it's not going to be adopted by businesses. You know, they've made billions of dollars of investment and they want to keep that. When you're developing your technology, I'm sure that someone out there has built a better Wi-Fi protocol, but it's not going to work with the way the technology works today. How important was it for you with Edgewater Wireless to, you know, for at least as far as the end user or businesses are concerned, it just works. You know, maybe they buy your hardware solution and everything else just works.
You know, through our work with Cable Labs and tier 1 service providers, one of the key things that was just highlighted or strongly encouraged by our partners was don't make me replace every device. Don't make me put software on every device. Don't change the world or those 20 billion devices. Do something that will help me with those 20 billion that are there today and the next 20 billion that are out there. So what we've done with Edgewater's spectrum slicing approach, and it's really one of the most powerful things that we can deliver to the market, is the fact that we're not saying, you know, Ben, I want you to rip and replace everything. I want you to throw out everything you have and start again. We're saying we can improve your performance in your home for your devices today, not just a little bit, but a lot. And I say that with much more confidence than we've ever been able to do in the past, simply because we've come out of a major a POC with a major tier one operator and a pilot. Really, the POC helped us identify and quantify the challenges that are in your home. And we did a comparison with the legacy single channel architecture to spectrum slicing, or the multi-channel or multi-link architecture. And what we found was that we could demonstrate anywhere from a 7 to 18 times performance gain in the home.
Wow.
So dramatic improvement. Not by doing everything under the sun, but very simply by reducing contention on each channel. So this was a big shift in our thinking, and helped us identify that there's a massive market opportunity in the home.
Yeah, and that's only going to be more and more important as, again, homes they certainly are going the way of wireless, and that there's nothing on my mind that's going to make me change that idea. But I also wanted to just kind of poking around your website. I apologize if I'm getting ahead of you, but this proof of concept that you had, showing such drastic improvements in the home. Is that, on your site here, you have a page about power zoning. Is that what kind of led you to those improvements, or is power zoning something a little bit different?
Power zoning amplifies that performance gain. And this is, when the proof of concept, we simply divided the number of devices over more channels. So you're going from, one channel in 2.4 and one channel in 5 gigahertz to 6, right? Is that better? Quantifiably, yes. Now, as we layer additional we've got additional feature and functionality within our silicon that allows us to do something called power zoning. Right. And that's controlling the power to each one of those channels. So we're operating, let's say, 3 channels in 2.4 gigahertz. They don't all have to be set to loud. Right. You can have a primary channel, which would give you more distance, and then secondary channels, which will give you less distance. Right. And what that does is it reduces the interference, and it allows you to optimally control what's going on from a performance perspective. So that's another way to, level up the performance even further than what we saw in the POC. Now, the one thing that was pretty exciting about working with this major tier one operator is obviously showing a 7 to 18 times performance gain for in the home is a big deal, and it was enough that they wanted to take us into a third-party, independent lab and say, give us a beta of your silicon. So very early run of your new silicon, and let's put it through its paces. We'll replicate those scenarios we saw in the home. So we took the silicon, wrapped an access point around it, one of our reference designs, and put it in a lab. Now, it's not the traditional lab that you hear, people quoting numbers from, right? It's not a Faraday chamber with no other devices around. This was actually a house within a lab. So replicating a house, really cool stuff. And, what they did was say, we've got a collection of devices in the home. We've got, homes that have 5 devices, homes that have, 30, 40 devices, and everything in between. There are a variety of Wi-Fi protocols. Let's put them all in there. There are a variety of distances. There's walls. There's all sorts of stuff happening in that house. Oh, and by the way, we're going to turn on an interference generator, and we're going to add interference. So it's one of those things. All of the hurdles that really, as a vendor, make you sweat. Right? Like, oh gosh, we had the theory and the math behind what we do says, we'll perform well there. But, the reality, we did really well. Our results mirrored the proof of concept. right? Which is
That's
really
great.
exciting. And yeah, and that's using all the existing devices. So a lot of what you'll hear about in the the upcoming weeks and months, the industry is going through a massive shift at the moment, right? We're it feels like we've gone from Wi-Fi 5 and just skipped over to Wi-Fi 7. And so you're seeing a lot of folks announcing their new Wi-Fi 7 platforms and things, and the fine print that really is not being communicated with the market is yet again, you've got to replace all of your devices, and you've got to hide away in a Faraday chamber to get some of these performance numbers. Now,
yeah, that seems to be the case, and the same thing happens in, like, let's say processors for computers, where they're like, we were able to cap that out at 60 gigahertz, 7 gigahertz, and it's like, well, yeah, we were in a lab and we had liquid nitrogen cooling the thing, and it was very, very good. That's not a real world scenario, so I'm glad that your real world scenarios more mirrored what you were seeing.
Well, and this was. This was just so important for us based on the feedback from the market and our target customers. And so what we did over the last while is we took all of that feedback and we synthesized that and said, how do we create a better product for the home? And this is what's really led us to our new product platform. And our new product platform, we've gone from and we've really tried to take advantage of the shift to Wi-Fi 7. Now, there's some exciting things that a lot of folks are talking about for Wi-Fi 7. The standard things that Wi-Fi has done over and over and over again, right? Which is, let's get a better burst rate speed simply by doubling the channel width. So We've gone from a 20 to a 40 to an 80 to 160, and now a 320 megahertz wide channel. And the only reason why a 320 megahertz wide channel is being talked about is 320 doesn't fit in 2.4, 320 doesn't fit in 5 gigahertz particularly well. The new 6 gigahertz allows for a little, it's supposed to be an uncongested spectrum.
Right.
So what that allows you to do is increase the QAM rate and get a better burst rate. Now, recently, and I'll go back to the conference that we attended, the Wireless Broadband Alliance conference and the Network X show. We heard from service provider after service provider that there's challenges in the home. Now, one of the key things that we identified in the proof of concept, where we looked at 6 million devices and 750,000 homes, is we saw that uniformly every device in the 2.4 gigahertz spectrum was connecting on a 20 megahertz wide channel, despite being able to support a 40. And in 5 gigahertz, the vast majority of devices in that POC could connect at 160, let's say, but they were only able to do a 20 or a 40 meg wide channel.
Do you attribute that to the fact that, even though these devices may come from, thousands and thousands of different vendors and, a lot of different companies can make these devices, the wireless chips only come from a handful of different providers around the world. There's only so many that actually make these chips. And I guess, they don't want those support calls that you're talking about being like, hey, my device doesn't work. So they kind of go with the least common denominator. It may not be as fast or as, it may not ease congestion, but it's almost guaranteed to work at the 20 instead of the 40 or the 80 or what have you. Do you think it's just, that's the default and a few companies kind of just set the defaults and no one ever bothers to change it?
It's a little bit of that. there's been surprisingly little innovation in the Wi-Fi chip space, right? Like it has again followed the same architecture all the way along. Now, the real thing that the POC and feedback from the operators has picked up on is Wi-Fi is an enormously robust protocol, right? It's designed to give you a connection. There could be interference, there could be a bunch of things going on, but it really wants to connect you. And in doing that, what it generally does is it tries to start out with a wide channel. And then it says, well, gosh, the 160 is not available. I'll back off to an 80 and to a 40 and finally to a 20. And so that back off is what we're seeing. Now, the things that cause the channel to back off to a narrower, or cause it to back off to a narrower channel are things like attenuation, so distance or walls from the access point, interference. Is there a lot of noise around, which forces you to use a narrower channel, or contention? Are there a lot of devices on there? And so one of the key findings from the proof of concept was that every time you added a device, the aggregate throughput coming out the back end of the access point, a nice quantifiable number. Every time you added a device, you'd think more devices, hey, there'd be more data coming out the back end. Right. It was the opposite. Every time you added a device, the data would go down at a very, very sharp graph down. So this indicated to us, which was quite encouraging, was that the majority of homes, a wide channel is simply not available. And so the POC said that. We heard some operators talking about that, but I think very recently a couple of the bigger vendors, like the folks providing optimization software, like Plume or Ekahau, the folks that actually see the performance stuff, right? They've posted statistics that say 90% of customers run a 20 to 40 megahertz wide channel. And that is a physical spectrum, like a physical limitation. No amount of software is going to fix the channel availability challenge.
So it seems like they keep releasing standards and they keep improving, but everything just seems to keep falling back to the same problems and falling back to essentially Wi-Fi that we've been using for 10, 15 years. So that's why I guess this question here, why we're not seeing much improvement. And that's where I'm assuming spectrum splitting kind of comes into play, and it can start to, speed things up, spread things out, get them onto those wider channels.
Well, that's it. So we've been shipping we as the industry, the industry has been shipping devices that support an 80 megahertz wide channel since 2014, right? And so there's enough time for all those devices to get out there. It's not really changing what's happening in the home. And now with we've sort of accelerated or skipped over Wi-Fi 6 for a number of reasons, but it supports 160 megahertz wide channel. And what the data shows is that's just not available in the home. It's not available in enterprises, and it's certainly not available in venues.
Gotcha.
So we really picked up on that theme. And use that data to build a better product.
So with and with all the data, and I'm actually kind of curious if this is something that the software solutions are working on, or if this is something that you work on, with more channels and all the different kinds of devices. I think that people are, very intuitively can kind of say that, my Netflix stream is more important, to have a faster, steadier connection than my connected dishwasher, which only needs to connect, maybe, once or twice over the course of its running. Or my security cameras need a much more stable, steady connection than, my internet connected doorbell ringer. Is that something that, spectrum splitting and, maybe giving things a more dedicated, uncongested or uncontested spectrum, or is that something that the software side handles?
Spectrum slicing actually gives the platform necessary to do that. So in many cases, like you look at a Wi-Fi security camera, those cameras are often still shipped with 802.11a and B and G chips inside them because they're low cost. And because, frankly, the camera is out on the edge of your house, right? Like, or it's out by your garage or whatever, wherever your cameras may be that are at a distance. So using that narrower channel makes sense. However, keeping that uncongested is the key. So with spectrum slicing, we allow that flexibility to, support those more devices and really give. We force multiply software applications, right? Suddenly they have more channels to work with, and they can actually optimize performance in a very big way.
Perfect. Yeah, and that's going to be huge and really the improvement I think people want. It's not that Netflix needs 200 gigahertz or I'm sorry 200 gigabytes per second to do Netflix things. It's just that, hey, you want these things to be more steady and more consistent. And of course we've been talking about the home a lot, and because there's very clear use cases for Edgewater there, but for businesses as well. You want to make sure that your point of sale systems are always connected versus maybe the smart labels on the shelf that just need to be connected once in a while. Very, very important there. So let's talk about Edgewater Wireless more specifically. And I think last time you were on, we were talking about a hardware solution. You were developing your own silicone and or your own silicon and your own physical product. But also it sounds like you're talking about integrating your system in with other people. So when should I expect to see Edgewater Wireless in people's homes, or is this something that you're always open to working with partners and rolling your technology in with them? What is your, I guess, path to market, to quote the question?
That's a good question. So we have really three areas of our business. We're a fabless semiconductor, so we're a silicon play, developing silicon for use in residential, prosumer, and enterprise access points. And that's really the path that we've been taking there in terms of our path to market is we have been working very closely with a major tier one operator, getting our silicon designed into residential gateways, for example. Now, backstopping that, we have a suite of access points and reference designs, which are, again, powered by spectrum slicing silicon and are used typically in enterprise applications. Now, those reference designs also give OEM manufacturers a quick path to market, building an access point with spectrum slicing in it. All of that is based on Linux and sort of the open source approach. Mm-hmm. And finally, at the foundation of what we do, we've got over 26 granted patents at the core of what we do. And we have, there may be opportunities to license and monetize those through working with other silicon providers. So really three paths to market there.
Perfect. Yeah, and of course there's there's a lot to integrate there, and this entire time you are having to also contend with, and not that Wi-Fi 7 is really out there. I think I just saw like one press release for one router that's going to be kind of available, but it's not really expected till 2024. As new technologies come up, I mean, there's been a lot of consistency, as you just mentioned, going back to 2014. Things have been pretty slow to evolve, but at the same time, there is evolution. Is that something that you're having to contend with as, because you've been on the show for, I think, 3-4 years by now. How has the development of all the other Wi-Fi technology affected your business? Is that something that you keep having to, kind of try to keep up with, or is yours just, our solution still works, it's worked for 5 years, it will work for another 5 years, we're good to go?
That's a good question. I think one of the things that we're constantly doing is we are refining and evolving what we do, really innovating our approach to Wi-Fi and wireless, and gearing that towards our customers. So what information can we gather from our customers? What are their experiences like? What are their major challenges or pain points that we can help them solve? And so we're quite excited about where we're going from a product perspective. And I don't know whether you have the ability to share our latest data sheet, but we are launching our Wi-Fi 7 product. So this is the first Wi-Fi 7 product backed by or with spectrum slicing technology embedded in it. So this is a very innovative
real
approach.
Quick, if you like to kind of tell me where, because I'm looking at your press releases and things like that. Do you know where the data sheet? I could find that real quick so I could throw that up on the video.
Yeah, there should be one in your email.
Sure. I'll pull that up, but please continue. Actually, I think I just got it right. Wow. Yeah. Clicks. Here we go. Let me
literally hot off the presses.
Yeah. Seems like it. So let me just go ahead and pull that up. It will open, and spectrum slicing Evo 880 platform. And wow, I actually opened that. Let's see. Let's open it with maybe this one.
Should be a PDF. It should be a PDF for you.
Yeah. Okay. So I'm going to work on pulling this up, but let's go ahead and talk about it.
Perfect. So our new Evo 8800 platform is the first Wi-Fi 7 platform with spectrum slicing capabilities. Now you'll see a lot of the key features coming out, or the advanced features of Wi-Fi 7 coming out. The wider channels, 320 meg wide channels. 4K QAM and things, but really the most exciting feature that's coming out in Wi-Fi 7 is something called MLO, or multi-link operation. Now, I think when we last spoke, we talked a little bit about something called dual channel Wi-Fi, right? Which was the ability to connect from the access point to a device multiple channels. So have a control channel and then a dedicated downlink channel. Now, if we fast forward to today, that dual channel Wi-Fi like feature is now part of the Wi-Fi 7 feature and functionality, which is really exciting for us, because our capability is the first and only to offer in-band and out-of-band MLO. So connecting channels in 2.4, 5, and 6 gigahertz, which is fine, but they all go different distances. What we can do with in-band MLO is we can connect within the same spectrum, whether it's multiple 2.4, 5, or 6 gigahertz channels. So it offers a new level of flexibility and granular control of the spectrum that hasn't been seen in Wi-Fi before. Now, one of the key things that we talked about in working with some of these large service providers, a lot of the marketing for Wi-Fi is always around faster, faster, faster. So having to support a speed test, that you go and you check a burst rate speed test from, whatever your favorite provider is. Mm-hmm. Now, in order to do that, having wide channel support is key. So what we've done with this new platform is we start with a wide channel. And if that wide channel is available, we can use the wide channel. Now, if that wide channel is not available, so if you go a little bit further down on the data sheet, there's a nice graphic there. It says, if that wide channel isn't available, we'll go into multiple narrower channels. So just a little bit there, the graphic on the right there.
So right now you have for everyone that's just listening, there's a little graph here, and think of it like a branching tree, kind of going down 260s, 480s. I'm assuming that's like what 248. That's the next number, and then 1620 megahertz bandwidths. Yeah, makes a lot of sense.
That's it. And so what that allows you to do or allows the access point to do is to really optimize the channel width and the performance that the device and the environment needs real time. Now, using this approach, we've showed anywhere from 7 to 18 times performance gains. And one of the key things to come out of our recent proof of concept is something that we as the vendor didn't set out to look at, but both the major tier 1 service provider and the test house raised their hands, partway through the testing and said, hey, wait a minute. You've provided a 50% improvement to latency. So we've reduced latency for all of those devices, which is, latency is probably the biggest concern of service providers. Whether you're streaming your Netflix, you can have all the bandwidth in the world, but if your latency is bad, your video is going to pixelate.
And of course, you of course run your website, and we run our website, and you learn very quickly that if people wait longer than like 3 to 5 seconds, they have a high chance of just leaving your website altogether. The ability for communication to happen quickly, seamlessly. People are I think at this point programmed that if something takes too long, it's not worth doing. So lower latency, I'm sure, is just everyone's dream. So yeah.
That's right. And so, our new platform provides the highest link or channel density in the industry. Right, we're supporting more links than anyone else has. It offers in-band and out-band multi-link architecture. Now, from a service and features perspective, we've sort of bucketed things in 3 areas: monitor, analyze, and control. So your device, we monitor the connections and the devices that are out there, see what's going on in the spectrum, right? We can also run that SSA, or that spectral awareness. We analyze what's happening on the network, from both an RF perspective and even an application layer perspective. And then finally, we control where the traffic is. Are we doing a single wide channel? Are we doing multiple narrower channels? So this monitor, analyze, and control gives service providers an enormous amount of flexibility and really a future-proof way to deliver those services that are there. Now, the cool thing, just going back, and probably the most important thing about this is, the 7 to 18 times and the 50% lower latency. That's not, me as a chip vendor saying only use my chips in a Faraday chamber. We've had enough of that, right? As a industry and as a user, this is using existing devices, which is really, really cool, and one of the most powerful things we can do to really address those customer care calls that are coming into service providers.
Yeah, and don't get me wrong, I'm sure that it's a great selling point for for people who make devices that are like, oh, if you upgrade your laptop, if you upgrade your tablet, you're going to get 10 times increased speed and all that kind of thing. But I think you're right, and I'm glad that the industry is kind of talking in conferences about that people don't want to wait until they upgrade their next device. They want that speed now, and the fact that you can do it for all devices is even better. So thank you for the spreadsheet, and we'll be sure to make this available in the show notes for anyone out there who would like to give this a look. But yeah, this is this is really incredible. And of course, all of this is and you mentioned here that you take advantage of the the 2.4, 5, and 6. Is this something that again, Wi-Fi 7 is supposed to be the new standard by 2024? Is this something that you're kind of working to get in before that? Is this something we'll hopefully see in the next year?
I think we, like many of our customers, are trying to pull it forward. I think there's been a real concerted effort to accelerate past Wi-Fi 6, Wi-Fi 6E in favor of Wi-Fi 7, and that's really that the MLO feature, it's been called the marquee feature of Wi-Fi 7. So I think that's what's really drawing people towards there. And we'll see, 2023 is really where we'll start seeing some of those devices hit the market en masse.
Perfect. So, and I think with that, I'm going to, and by the way, this interview was supposed to be about a 30-minute interview, but I've had so much fun talking to you, and it's almost an hour, so I apologize for taking, too much of your time. But I'm going to leave you with the question of: is there any areas that we didn't get to touch on, or anything that you'd like to discuss before we kind of wrap it up?
I think we've pretty much covered everything that we'd like to. Our new platform's pretty exciting. Keep an eye out for new things to come, and we appreciate the time.
Yeah, our pleasure. And everyone, once again, that's edgewaterwireless.com if you'd like to find out more. I said this before the show, but the new website looks spiffy. And ladies and gentlemen, there's a lot of great information there, as well as case studies and more. So, ladies and gentlemen, if you'd like to find that out, again, computeramerica.com will have a link in the show notes to that exactly. So, everyone, we have been talking to President and CEO of Edgewater Wireless, Mr. Andrew Skafel. And it's been a lot of fun, Andrew. It always is. Thank you so much for coming back on.
Thanks for having me, Ben.
Our pleasure. So everyone, until next time, computeramerica.com again for everything. And until next time, have a great one. Bye-bye.